You know, so now we want to see what could we do to have a function inside of another function. Okay? And then we can write out of our equations. And there is a shortcut for these ones as well. Remember, for adding functions, you made one function exactly the same, and then you made the next function just 0. For multiplying and dividing, we made one function exactly the same, and the next function was just 1. So there's a shortcut for this one as well. Although for these ones, it's not too hard to see a function inside of another function. So for A, okay, we need to find a function inside of another function. Can you see that one function here is cubing something? And inside of the cubing is a line. X minus 2 is a line that's inside of the function. So if we made our inside function be the line, what's happening to that line? Our outside function would be cubing it. So then if you were to write f of g of x, you would have f of x minus 2, and then you would plug x minus 2 in for x and cube it, and it would work out. So we're looking for a function inside of another function. For the square root of 3 plus x, can you see that 3 plus x is inside the square root? So if we make our inside function 3 plus x, and say that is inside of a square root, then when we do f of g of x, we would have f of, 3 plus x, and then f takes whatever you put in and square roots it. Now with our other ones, we always found a shortcut that always worked. Can you see a shortcut that would always work for composition of functions? Well, adding 0 wouldn't, okay, you're right, we can make one of our functions. Let's make one of our functions exactly what we started with. So in both cases, that would look like this. What would the other function be so that it would stay the same? Just keep f of x equal to x. And that will always work as a shortcut for these. Because what does f of x do? Whatever you put in stays the same. That's what f of x equals x. You put in 2, it's 2. You put in k, it's k. So if you would put in f of g of x, if you would plug in x minus 2 cubed into f of x, all that's going to happen is it's going to stay x minus 2 cubed. So that can be a shortcut for composition functions. I find, though, with composition of functions, it's not too hard to see a function inside of another function, for the most part. But if it was a difficult one that you couldn't see a function inside of a function, this would work. Yeah. Not 3 plus x, just because I copied it wrong? Yeah. Yes? A hard to see composition one? Something like this. My function inside, I would say, is x plus 3. My function outside is x squared. Because if you were to factor this, that would be x plus 3 squared. Okay? Another example of one that might be a little bit harder. Okay? My function inside could be the x plus 3. Okay? And then my function outside, well, is x squared plus 5x plus 7. Yeah. So those ones could be harder ones to see when it's inside and outside. Can you see that wherever I have an x right here, I'm putting in an x plus 3 up here, and so that's one function inside of another one. Did I give you the questions yet for these ones? Okay, questions 3, 7, and 9. Yes?